Welcome. Testing, 1, 2, 3. So unless I'm confused, this should be the Agile architecting talk. Is that true? Our expectations are in sync? Good. Well, before I go any further, I'd want to underline, I didn't call it Agile architecture, I called it Agile architecting, to emphasize the point that it's primarily an act rather than a thing. And Agile architectures only really come from Agile architecting. Now, in addition to my background related to Agile methods, to kind of make the connection to software technologies and architecture, I'm the author of this book related to software design, and I have a background on high-performance computing and so forth. I usually work in embedded systems, large embedded systems, so that's the world I know best. Okay, so I'm just going to run through a series of tips here in no particular order. The first is the following. I am so glad I have a mother, because I've been working in software development and product development for 30 years, and I understand what's inside this box, and that makes me dangerous, because that means I no longer can see a product from the viewpoint of my mother. But I really need to, because they're the ones who use the product, and I've kind of lost the ability to get a sense of what I consider to be a terribly important point, which is that for 99% of the people in the world, the interface is the product. And the user interface is absolutely critical, and there's, in my humble opinion, a gross underemphasis on the critical importance of interaction design. User interaction design, in my opinion, is absolutely critical, and for people involved in Agile architecting to not emphasize this, but to instead to focus on the lower levels is a gross mistake. If you get the lower levels right and the interface is wrong, nothing meaningful has really been done. Technical success is not success. It needs to be success in the eyes of the customer. So Agile architects learn more about interaction design. Agile architects pay attention to the architecture at the interface level. Agile architects encourage or require the hiring and developing of people with special interaction design skill and really focus on that. I'm not talking about a waterfall development process, but in the context of Scrum and in the context of software design, I'm saying that every sprint, the interface is critical. That includes usability analysis and so forth. Now, kind of slightly flip topics. Where is the software architecture? I usually work in embedded systems where there's a combination of hardware, either medical devices or others, and software. But let's just talk about software for the minute. Where is the software architecture? Famous paper, What is Software Design by Jack Reeves, 1992. The only software documentation that actually seems to satisfy the criteria of an engineering design is the source code. Now, I'm the author of a book called Applying UML and Patterns. Unified Modeling Language is a visual language for doing diagrams about design. And people are sometimes surprised when I start working with groups. They think that, for example, that I would want to use case tools or do lots of fancy diagrams. But I'm a programmer, and I've been a hands-on programmer since the 1970s, and I'm not confused. I understand that the source code is the only real design. That doesn't mean that sketches and diagrams aren't useful. They can be. But this is the reality of where the real design is. And there's a problem that has arisen in the world of people who don't do software development, and amongst some so-called software architects who seem to think that coding is not design, but is some kind of construction or manufacturing activity after design. Who seem to think that the programmer is not a designer, but is just some kind of construction person doing the minor last end bit. But the reality is that writing the source code is the real design. And when we execute the build item on the menu, we're doing construction. The extraordinary thing about software development is that construction or manufacturing is essentially free. It's when we're doing compiling. And these days, compiling happens so fast you don't really have a sense of it. But back in the 1970s, when I would have to submit a compile, I could hear the bits being manufactured. 1, clunk. Tuk, 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 tuk. 0, clunk. You could hear the bits being manufactured. But these days it so happens so fast, you don't see that compilation is the manufacturing step. So you get this mental model mistake. Like, for example, if you're building a car, you have this step that we'll call blueprinting, and then a step called production. And it's pretty clear when you're building cars that blueprinting is the design and production is the manufacturing. So then a thinking mistake is, for example, something like a UML diagram is the design step, and then coding is the production step. But that's a profound mistake. In fact, the reality is it's coding that is the design step, and then compilation is the manufacturing step. Now, why did I spend 2 minutes emphasizing this point? Because it leads, therefore, to a critical point, which is that this is not true, and that software coding is the real design activity, and therefore we need to code the architecture. Where is the real architectural quality? This is a wonderful diagram by Bob Martin. The only valid measure of code quality is what the fucks per minute. Good quote, code review. What the fuck? Bad code. What the fuck? What is this shit? And that is so true. So really understanding architectural quality is really measured in what the fucks per minute with respect to your source code. Jim Copleen was involved in a study of hyper-productive development teams back in the 1990s, and one of the qualities of these teams was that the architect worked as a programmer. The architect was a master programmer. No PowerPoint architects, that's the key point I want to make here about agile architecting. No architecture astronauts, which are so high in outer space, there's no oxygen left. And we can't interact with them because we can't breathe anymore. We're going to look at the big picture. Okay, well, no problem looking at the big picture, but the reality is the source code. So if your so-called architects are what in Canada we call PowerPoint architects, you're not going to have agile architecting, and you're not going to have an agile architecture. And so I urge you to, if possible, expel or get rid of PowerPoint architects and hire and establish a culture of coding the architecture. And this is no false dichotomy. I don't mean there's anything wrong with UML sketching. I don't mean there's anything wrong with architectural view discussion and diagrams and documents. All I'm saying is that the leading architects need to have their hands in the real code where the real design is done, or things will go terribly bad. Another comment about agile architects and architecting is that, and this is analogous to the Toyota model, in Toyota there's a culture of more senior engineers, the team leads, act as mentors and coaches. And good agile architects mentor, for example, while at the wall doing agile modeling or while doing pair programming, rather than creating documents and then handing them off to other people, or creating PowerPoint diagrams and saying, here's the architecture. And because most systems have a lot of what is euphemistically called legacy code, or more commonly called crap, and lots of it, good Agile architects understand the skills of how to improve legacy code. Good Agile architects have really studied books like Working Effectively with Legacy Code and know how to get rid of this mess and break the dependencies and start to bring things under test and isolation and to be able to inject dependencies and so forth. And good Agile architects not only understand these techniques, but they mentor them to other programmers, hands-on working with the code. And good Agile architects mentor during design workshops. I encourage every sprint in Scrum, if this is a sprint, that suppose, for example, in Scrum you're doing 3 items, item 1, item 2, item 3, that in between or shortly before each of these items, the team stands up, they head to their whiteboards. This is how I typically set up my team rooms. Dining room table style near the center, the walls are free, and then the walls are covered in whiteboards. And then the teams, along with an architectural leader, can coach and discuss. And by the way, while I'm thinking about physical environment here, as you can see, this room here didn't have whiteboards, but I emphasize this for almost 30 years. One of the themes of my coaching and work has been to use massive whiteboard space, and I consider massive whiteboard space to be one of the critical magical keys for really successful modeling. And whiteboard space doesn't necessarily mean that you've got traditional whiteboards. Like, for example, you can get this kind of stuff which comes in rolls of like 100 meters or so. And it goes by different names in Europe, like Easy Flip and Magic Chart. And this is just a small part of it. But it clings to walls, it clings to glass, and then you can see, like here, you can just roll it out across the walls, and it works like a whiteboard. You can use whiteboard markers on it, you can erase them, and so forth. So you can take over a hallway or take over any room where there's big wall space, or in your team room, you can set up these giant whiteboard spaces. This is one of my clients here, for example. This is Norwegian Cruise Lines, by the way. Norwegian Cruise Lines years ago adopted Scrum, and this is one of their team rooms. And they've got floor-to-ceiling, wall-to-wall whiteboards. And how they did it was that the Scrum Master was fixing his bathroom, and he was changing his shower. He was changing the walls. And he was at the hardware store buying the waterproofing material for his shower walls. And it's like this thin white plastic. And it's really cheap. It's like 5 or 10 euros for a big panel of the stuff. And he realized that it worked just like a whiteboard. And so he spent, I don't know, 150 euros. He put a whole bunch of these panels for the bathrooms in his truck. He drove to the team room, and then he just screwed them into the walls. So this is literally floor-to-ceiling whiteboards done for, you know, like 150 euros. These are the kinds of things that good Scrum Masters do. You know, you've got a good Scrum Master when that kind of innovation and support is happening. And one of the things that I've encouraged for a long time is Agile modeling. And people sometimes don't understand this about my coaching and system of thought because, for example, in my books, like Applying UML and Pattern, I present diagrams in a nice and neat tool so that people can make it legible and that people can read it. But in reality, how I do modeling is sketching on the walls, where the emphasis is conversation, communication, collaboration, and creative discovery, and there's a de-emphasis on things like notation and so forth, and the modeling at the walls. And I encourage people having some basic skill in UML notation, but not that I care about the UML, but just that we have some common language with which to express our ideas, activity diagrams, communication diagrams, and so forth. Now, this is my bias, and this tip is more controversial, and I'm not sure it's actually kind of like a sort of universal truth. I'm an old Smalltalk programmer from the early 80s and so forth. And in the Smalltalk world, there was this emphasis on this really clean separation of concerns into a domain layer of objects, model objects, which really represent the domain concepts and domain logic, clearly separated, for example, from a view layer. And in a related point, this domain layer in the world of object-oriented analysis and design that I come from, the domain layer reflects our mental model of the domain. So that if I'm building printer software and my world is concepts like a print job and a PDF document and so forth, then I would expect to see in software land objects like a print job and a PDF document and so forth. In other words, the mental model of the domain concepts is reflected sort of one-to-one or isomorphically in a domain layer. And this is related to something called domain-driven design. And I happen to think that domain-driven design is a good thing. But this is open to debate, and I can come up with examples where it's not a good thing, where it might be, for example, over-engineering. But nevertheless, I encourage Agile architects to understand the ideas of domain-driven design and at least have the capacity to coach it where appropriate. We've talked about that. And I can't assume that people were in my previous talks today, so although I've mentioned design workshops before, I'll mention them again. One of the recommended ideas when you're scaling is to have a joint design workshop, and for people involved in architecture to be involved in these. So if we've got these individual design workshops for one team, if on the other hand there's, let's say, 9 or 10 teams involved in each sprint, then I recommend a joint design workshop, which happens sometime each sprint, and representatives from each of this team join it. And these representatives will be people in a community of practice related to architecture and design. And these Agile architects will then be at this joint design workshop. They'll look like this, but it will now be at the level of the system rather than just of the team or of an individual feature. And then at the joint design workshop, they can come up with solutions or ideas that relate to this higher level. And then when they go back to their individual teams, they can communicate these ideas. In Scrum, there's nobody outside of the team. There's no architecture group. There's no architect who is not a hands-on worker in a team. So if, for example, this person was involved in architectural work or some kind of architectural leader, they would also be a hands-on team member in a Scrum team building real features. And I stress this point that I've just said, that Agile architects are members of Scrum teams, because it's very common that when I'm involved in Scrum adoptions, that every specialized group, when they hear about cross-functional teams, they'll say, well, yeah, that applies to them, but not to me. It's very common when I go to companies that say, oh, yeah, we're doing Scrum. And then I go there, and then, yeah, we're doing Scrum, and there's the business analysis group, separate to the Scrum teams, that are creating documents and handing them off to the Scrum teams. And when I explain, no, there is no separate business analysis group, then there'll be a yes, but, da-da-da-da. or the interaction design team. They'll say, well, yeah, Scrum's for cross-functional teams, but not for us, or the database group or the architecture group. You'll get these excuses. But real Agile architects are hands-on members developing features on real Scrum teams. So, not that. And in Scrum, question, what is the name of the members of the Scrum team? What's the official role name in Scrum of the members of teams? Team member, and that's it. This does not mean generalists. In Scrum, this is often misunderstood. We're not talking about having generalists, but we're talking about multi-skilling or having multiple skills. So a person might have a primary skill and a secondary skill. For example, maybe my primary skill is that I understand the world of architectural concerns well, and that's my primary skill. But I'm working on a secondary skill that will help value throughput for the team, like customer documentation. Or someone else's primary skill might be testing, and their secondary skill might be interaction design. And so in that context, many people could temporarily play an architect role. If we say, well, she's the architect, then you could sort of say that in Scrum, but you would have to say that in a very light way, meaning to say better, well, she's the person who's currently playing that role as primary specialist, but that role could shift to someone else. So Agile modeling, to take a bit of a deeper dive into this subject, does not necessarily mean only using whiteboards, but certainly whiteboards are an important part of Agile modeling. And so Agile architects are looking for ways to increase the amount of whiteboard space and are making sure people have got lots of fresh black marker pens and are encouraging this kind of sketching as a context for group discussion and collaboration. And Agile modeling, which doesn't just imply using whiteboards, but more broadly implies using simple tools which encourage creativity, flow, and collaboration, includes things like, paper modeling for user interfaces and other possible lightweight modeling techniques as well. And good Agile architects are skilled in understanding many of these lightweight modeling techniques, and if they're involved in facilitating a design workshop, can help other members learn and apply these. And Agile architects encourage people to understand that every model is wrong, and that's okay, because the modeling that we do here is just a context for conversation. It's inspiration, it's not documentation. We model to have a conversation. We don't model to document. And related to this, I sometimes get requests for a recommended UML case tool to use when we're doing modeling. And I urge Agile architects and everyone to avoid any kind of UML case tools, because this is really just a technology problem. It's not that there's anything inherently wrong with a UML case tool, but in 2009, they inhibit creativity, flow, and collaboration. And it's related to the user interfaces. Because what we want is simple tools with which we can move fast and we can focus on the important stuff, which is creative collaboration. And if we've got big whiteboards and are using marker pens, that's easy. If we're using a computer software tool in 2009, that's difficult in terms of usability. But I'm sure that in 50 or 150 years, we'll have sort of virtual interfaces where I can move my hands and there's things floating in the air, and through augmented reality technology and so forth, I can manipulate computer objects easily, and others can see them also. And when that comes, I won't have any problem using computer-based modeling tools. And Agile architects do not fall into what in English is called a false dichotomy. A false dichotomy is an argument that is set up with only two alternatives, two and only two alternatives, like programming good, modeling bad. And you hear these kinds of false dichotomies usually coming from the extreme programming and TDD community, who will get kind of fundamentalist or dogmatic that, oh no, modeling is to be avoided, it's wasteful. And I discourage that kind of false dichotomy for several reasons. First of all, I disagree with it from my experience. And secondly, it doesn't recognize that people have different learning and creative discovery styles. Not everyone has the same kind of modality of learning and thought. And third, humans are incredibly visual creatures. Big parts of our brains are dedicated to visual processing. And this way of having a conversation can often be effective for humans. There's been research in terms of static code analysis that has looked at, for example, the cyclomatic complexity of software systems, and I'm assuming you understand what I mean by cyclomatic complexity, and the number of defects. And the research shows that there is a linear correlation between cyclomatic complexity and number of defects. That's relevant because defects cost money. They cost hard money and they cost soft money. Now, to go to the next step, so this is what we know, that there's this relationship between increasing cyclomatic complexity and defects. In addition, there's research to show that for products created with test-driven development, there's an inverse relationship on cyclomatic complexity. In other words, in the research studies that have been done, products where more TDD was done, cyclomatic complexity was lower. So therefore, we know that test-driven development tends to encourage low cyclomatic complexity, lower coupling, and less defects. And therefore, in that sense, it encourages a better architecture. So good Agile architects are test-driven, both at the unit level and the acceptance level, and they're hands-on masters of test-driven development. Both they're hands-on masters of unit TDD and of acceptance TDD, and they can mentor people in those skills. I sometimes visit groups that are buying tools or buying frameworks or buying products that they might be integrating with. Let's take SAP as an example, and I don't mean to pick on SAP. And architects may be involved in the choice of these frameworks, components, or products that are going to be integrated and then used to solve some business problem. And unfortunately, I often see the case that these products are not amenable to automated test, or the only way you can do automated test is through the GUI. There's no way to test these third-party products that you're integrating below the GUI. And I hope that Agile architects understand that's a really bad situation, and that good Agile architects look for and require the acquisition of products which can be massively and thoroughly automated tested below the user interface, which implies that they've got APIs and architectural design that's appropriate for that. And Agile architects coach and understand acceptance test-driven development, which is largely about understanding the idea of requirements as executable tests or executable acceptance tests. And this involves using new methodology, using acceptance TDD methodology practices, for example, suggested in books like Bridging the Communication Gap and Fit for Software Development and Behavior-Driven Development and so forth, that Agile architects understand those things. And secondly, Agile architects are aware of modern, skillful technologies which can make acceptance TDD a reality. The best of these that I now know is called a robot framework. Is anyone here familiar with fit or fitness? So fit or fitness are okay, but they have a number of weaknesses, and there's a next generation after fit and fitness, and that's called robot framework. This was made years ago at Nokia for Agile Acceptance TDD and has been used at all levels of the stack, from embedded systems testing all the way up to browser testing, and it realizes the concepts of keyword-driven testing and user-defined keywords, and it supports acceptance TDD, and it's powerful stuff, and I encourage you to learn robot framework and use it. It definitely goes farther and more powerfully farther than technologies like Fit. And just to provide some context for this, because I've observed that many people aren't necessarily familiar about how to do acceptance TDD, the place to start is really on flip charts or whiteboards, where you're discussing with the people responsibility for defining requirements or for defining acceptance in a keyword-based, table-driven approach, but in an approach that we'll call pseudo-robot framework or pseudo-fit. And then these are being done in workshops each sprint. And now to connect this to Scrum, one of the rules in Scrum, and by the way, this I've noticed is the least known rule in Scrum. Well, perhaps not the least known rule, but one of the least known rules in Scrum is that minimum of 5, maximum of 10% of every sprint must be spent by the team on what's called product backlog refinement or grooming, where the team is doing splitting of big requirements into smaller one, low-level requirements analysis, and re-estimating the entire release backlog. And Scrum does not say how this is done, but it's relatively common for it to be done in a workshop, a focused workshop. And when I'm coaching teams, we usually do it near the end of the sprint, because it's not for the current sprint, it's to support future sprints. And then this kind of work of doing modeling to define the acceptance tests in pseudo-robot happens during the product backlog refinement workshops that happen every sprint in Scrum. And Agile architects are really enthusiastic and understand the ideas of dependency injection and encourage this. This leads to all kinds of good things. Using either existing frameworks like Spring or Spring.net, or just homegrown simple dependency injection with constructor parameter dependency injection and so on and so forth. And increasing degrees of freedom with polymorphism or data-driven approaches and so forth. And agile architects understand and can mentor people in the use of patterns, design patterns, architectural patterns, and so forth. And good agile architects also understand the disease that I call patternitis. Can anyone guess what patternitis is? It's a terrible illness in software development. Yeah. Yeah, it's either trying to conform to patterns or trying to use patterns when they're not really motivated. So there's this saying in Canada, I have a hammer and everything looks like a thumb. So, there's a journey of a software developer. And years ago, I wrote an article in IEEE Software on kind of the journey of a software designer, a professional. And in it, I was reminded of a famous Chinese Buddhist sutra called the Diamond Sutra. And in the Diamond Sutra, there's this famous stanza in Chinese Buddhism. How does it go? Essentially, to simplify it, it says, before learning the teachings of the Buddha and the teachings of enlightenment, mountains were mountains and rivers were rivers. After being introduced to the teachings of meditation and enlightenment, mountains were no longer mountains and rivers were no longer rivers. After enlightenment, mountains were mountains and rivers were rivers. And in a way, this famous sutra kind of describes the journey of the software professional with respect to design skill and design patterns. And what happens is there's this intermediate area where developers and designers learn a lot of techniques for flexibility with patterns, data-driven techniques, dependency injection, and so on and so forth. And then I see a kind of ugly mismatch of over-engineering. I'll see J2EE or all of this unnecessary overhead when real expert architects design simply and only introduced complexity when in some way it addresses another problem. There's some variation point in the architecture that needs to be resolved with the introduction of a pattern. And really good agile architects design simply unless they don't need to. And good agile architects understand that architectural design, or designing at the systems level, is not done just once, but is evolutionary based upon feedback, and are actively involved in engaging the teams in considering architectural design every sprint. And by the way, when I say architectural design, I've kind of assumed that we're speaking the same language. I mean, at an architectural level, consideration of the illities which go beyond just functionality. All of the non-functional and other quality attributes that need to be considered in the architecture. Maintainability, internationalization, and reliability, and so on and so forth. And that good agile architects are bringing these to the foreground in the joint design workshop discussions every sprint. And so related to this, agile architects encourage not thinking in terms of really big upfront modeling, but in terms of evolutionary modeling where things might evolve sprint by sprint. But this is another, I guess for some people, controversial point, but it's, in my opinion, perfectly sensible and useful. Agile architects encourage for big product development, especially if it's release 1 in a greenfield product, we need to spend 1 to 2 weeks in a room at the whiteboards before sprint 1, before we start building the real thing in detail, in my opinion. We need to be spending 1 or 2 weeks doing lots of agile modeling, programming spikes, doing tracer bullet implementations for key architecturally significant user stories before we start sprint 1. And I suppose there are people and teams and products that can avoid this and relatively successfully come out the other side. But I've done this enough over many years to actively encourage some degree of agile modeling and tracer bullet implementation before you're starting to build your real deliverable features for sprint 1. And I encourage this. Again, it's an example of moving beyond false dichotomies. This is not the waterfall, nor is it no modeling. And in good product development, we want to fail fast. And in good product development, we want to provoke and attack our risks, or as Tom Gilb would say, they will attack you. And so to fail fast and to provoke these risks, good agile architects are encouraging us to do user stories or items or features which will force us to confront core key architecturally risky things early on. Like, for example, a while ago I was working in Berlin with a group, and some of the user stories related to basically high concurrent access, where we needed to have 50 or 150 concurrent users or network element services in parallel being served by a particular network element. And that's architecturally significant, and early on you better be able to prove that. And we have to prove that in code. We can't prove that in a document. Now, speaking of documents, architectural documentation can be useful. How to create architectural documentation and when to create architectural documentation. Time, and here's a release. This is not a sprint, this is a release. So we've just spent, for example, 6 months in a series of sprints, and now we release. Since the only real architecture is the source code, we don't really know the true architecture until the source code is finished for the release. This, of course, is when the source code is finished for the release. So in my world, when I'm coaching groups or working in projects, I'll do the architectural documentation after we've released. And I'll do this, for example, here in what I call a SAD workshop, a software architecture documentation workshop, in which we're looking back at the completed system and describing it. We're not speculating what it may be like, we're describing what it actually is, and then once created, it can be a learning aid for the teams in the coming sprints. And how to do this, I recommend doing it in a SAD workshop, which literally looks like this. And I describe the model in chapter 39 of one of my books, which is basically the N+1 view model. You've got different views like the logical view, the data view, the deployment view, and some others. And in parallel, we've got different subgroups working on these different views. For example, this team might be working on the deployment view using, say, UML deployment diagrams. This team might be working on the data view. And then we do show and tell, where the different groups visit each other's models and then give feedback. Notice that the SAD workshop then becomes a context for learning, not only for creating documentation, but in this collaborative process, people will actually come to learn more about the architecture of the system in addition to actually creating the documentation. Then we take digital photos of all of these sketches and drop them onto different wiki pages, a deployment view wiki page and so forth. And then I recommend a technique which I learned from Ward Cunningham many years ago back in the 1990s called technical memos, which are also described in this chapter, where the idea is you have a relatively short one-page description of the, what in English we would call the tricky bits. How it works is we all get together for 15 or 20 minutes at a whiteboard and we brainstorm and we ask the question during this workshop, what are the tricky bits that we want to explain to people? And that can really widely vary. Oh yeah, there's this strange thing, or there's this important thing. And we come up with a list of 10 or 25 tricky bits. And then each of those gets its own technical memo, which will be on its own wiki page. We break up into pairs and we do pair writing, and then each pair works on a different technical memo. I explain a format for that in my book. And then we'll do review of the wiki pages. We can do rotation writing, where, for example, she and I write the page first, and then you two guys take on the wiki page after all, read it, and then evolve it. And this leads to then shared learning and collaborative evolution of the documentation. And this happens at the end of each release, or more frequently if there's some driving need. That's not usually the case when I'm working in Europe, where teams are relatively stable, but I've lived in Bangalore for many years. And in Bangalore, the annual attrition rate usually ranges between 20 and 27% every year. So you could say on average that 1/4 of your staff are going to disappear every year. That takes a big impact on the knowledge that your team has. And so in that context, when you've got more people coming frequently, there might be a need to do more intermediate SAD workshops to provide a learning aid for the people coming in, where you can say, welcome to the team, there's the wiki pages that describe the SAD, why don't you spend the morning reading that before we carry on. In the 1980s at HP, a requirements model, a requirements taxonomy was created and promoted, which is now known around the world. It's been promoted in the unified process and in other requirements approaches, which I encourage as well. And it's called the FERPS Plus model. And because architectural concerns, FERPS Plus, because architectural concerns move beyond the functional to these other areas, I encourage Agile architects to know this model and to coach this model. This is the official breakdown of the FERPS Plus model. If you go to Wikipedia, you can also find it as well. And of course, these are the kinds of things that architects need to be aware of. Now, the nice thing about the FERPS Plus model is that it's such a simple, memorable acronym that we don't need to really get lost in a lot of detail of requirements models to apply it. Here's the key point. If you understand and remember FERPS Plus, you can apply this thinking to any requirements model that you use. You're doing user stories and acceptance tests. Did we consider FERPS Plus? You're doing use cases. Did we consider FERPS Plus? You're using Tom Gilb's language. Did we consider FERPS Plus? We're just thinking about writing acceptance tests in FIT or robot framework. Did we consider FERPS Plus? We're defining the sprint definition of done, likewise. And so it's a very simple teaching tool to get good architectural concerns coverage. And relating FERPS Plus to acceptance TDD, I think good Agile architects understand that you can connect the URPS plus goals to automated acceptance tests. All too often when I go and visit teams who are starting to think about acceptance test-driven development or system-level automated tests, they only focus on the functional, and I think good Agile architects are encouraging automated tests in these other areas as well. And the most sort of usable and used approaches that I've seen for recording, understanding, and remembering the non-functionals is in wikis. And I'll just sort of broaden this comment a little bit. For reasons which are not clear to me, I've noticed that some groups are continuing to work with old 1970s and 80s technologies like Microsoft Word and SharePoint and these other old technologies, which are basically document-centric. The emphasis is things are in separate documents. And in general, I think good Agile architects, and certainly the most successful sort of tool-level approach I've seen, moves really to a Web 2.0 model for information, where we stop working in documents, we stop using document-centric tools, and we move basically to Web 2.0 or Web 3.0 models, where we're using wikis and wiki-like technology for everything, requirements, non-functionals, and so forth. Another thing that good Agile architects do is that they encourage user story splitting via an API when there's a graphical user interface involved. So for example, suppose you've got a user story that ultimately, as a network planner, I need to configure a media gateway via a GUI. Good Agile architects encourage implementing a variant of this user story that can be executed and tested through an API so that we're ensuring there's no application logic in the UI layer. If we have a UI layer and an application logic layer, and Agile architects are encouraging user stories like this, then that will imply that we must put the application logic down here, and we must have automated tests that come in below the UI that test it. And in that way, we will encourage a much better architecture and much better testability. And then we'll do a GUI version after it. It's very common when I'm working in product development that I'll create these two twins in a sprint, and then I'll do this one first and this one second. Agile architects are learning Agile architecting. And there's lots of tips and stuff on the web and various books and so forth, and I encourage folks to read it, for example. And Agile architects avoid Conway's Law and component teams. Those of you who were with me in the previous session have been through this before, but I'll just introduce it again briefly. Mel Conway wrote a paper way back that was actually related to his PhD work called How Do Committees Invent? And one of the things that Conway observed was that suppose you want to make a compiler, and suppose you create 4 teams. You will have a 4-pass compiler. And what Conway observed was that the design of a thing will reflect, unless you're careful, the organizational structure of the committee or of the department. And Conway's observation was that's a really bad idea, but it happens all the time. So, for example, if we'll end up seeing that it goes both ways. If you have departments that are developing parts of the architecture, C1, C2, C3, these departments these are departments of people. These departments of people will tend to reinforce an architecture in which there's components C1, C2, and C3. If you have these three departments, to keep it simple, you'll get these three major modules. And Conway also observed the opposite, that if you have some major modules, C1, C2, and C3, big chunks of code in different modules, that you'll often get departments that form around them. In other words, Conway's law, which by the way he was not recommending, he was pointing it out as a really bad thing that goes on in organizations. Conway's law was that organizations often freeze around their architectural elements. And that's a really bad idea, he concluded. So watch out for this. And you get this with component teams. So if you've got, let's say, for example, 9 development teams, and these are your components, component 1, component 2, component 3, and then if you've got teams, you might then create teams around these components. The component 1 team, the component 2 team, or the UI team and the database team and so forth. And if you do that, you will have the waterfall. Those of you who were with me in the first session understand that. So Agile architects understand in depth the problem with component teams and why they lead to the waterfall, and Agile architects strongly discourage component teams. And Agile architects encourage continuous integration, where all the code across all of the sites is continually being tested in one place and at one time. My world is the world of large-scale multi-site development, where you might have a couple of hundred people in one country, a couple of hundred people in another country. Continuous integration does not mean that the China team does CI and that the Munich team does CI. It means that there's continuous integration across all 400 or 600 people 24/7 at all times. And Agile architects encourage static analysis tools like Sonar and JDepend, which are continually running and providing simple, lightweight signals that there might be something smelly in the code. And what I do is that I attach these tools to my continuous integration tool, like Cruise Control or Hudson, and then I'll fail the build. I will cause the build to fail in how I set up the scripts if, for example, Sonar's analysis indicates that some threshold has been crossed. And then that will help you not let the code and system drift. Agile architects understand the Scrum Sprint definition of done and how it can be used to improve the architecture and architectural concerns. For example, in the sprint definition of done, we can include non-functional requirements that are proved with acceptance tests. So you can actually say officially in the sprint definition of done, done implies that the reliability tests are passing, or done implies that the usability tests are passing. Now, some of those could be automated, some of those might involve human testing, but by adding these to the sprint definition of done, we raise the architectural concerns to a more visible level. Technical debt is a subject I think some of you already know about. And I think good Agile architects are working in the following area. I know I am at the moment with some of my customers, and that is trying to make the connection between technical debt and money. Because we all know that the cost of quality is a cost, and it has both direct costs and indirect costs. And I think good Agile architects are working in this relatively leading edge area of trying to create an economic case and a business model that can somehow quantify the cost of our technical debt to communicate to our business people that this costs us money and therefore there's a rational economic case to be made to reduce it. I think I'll skip that. Okay, done. Now, it's 10:15 or 11:15, and this is the official time to end the talk. And so after I just close off, then I'll be available for questions, and if you have any questions, I'll be glad to take them. I think I'll end the talk, though, with a bad joke. So an engineer walks into a bar. And he's a real handsome guy, just gorgeous guy, and girls just melt when they look at him. And he goes up to the bar and he orders a triple shot of whiskey with his friend, another engineer. And his other engineering friend says to him, "Hey, how come you're drinking so much?" And this handsome young engineer says, "Well, you see, I'm celebrating. I was walking to work this morning, and a beautiful young girl drove in front of me on her bicycle. And she got off the bike and she looked at me and she said, 'Baby, you are so gorgeous, you can have anything you want.' And she took all of her clothes off." "Wow," said the other engineer. "So what did you do?" "Well, I took her bike." "Oh, that was smart," said the other engineer. "I just know her clothes would not fit you." Thank you for your time.